Integration. Integration is applied in finding the areas of irregular shapes. It is the act of combining parts into a whole. Usually, integration is viewed as the reverse of differentiation. A recap of differentiation. If y is equal to x raised to power n, then dy over dx is equal to nx raised to n minus 1. The derivative of a polynomial is found by working out the derivative of each term in the polynomial. The derivative of a constant is always 0. Reverse differentiation. Consider the lines below. Y is 3x plus 1. Y is 3x minus 5. Y is 3x plus 25. The three lines are parallel with a gradient of 3. That is, dy over dx is equal to 3. Any of these lines has an equation of y is equal to 3x plus c, where c is a constant. Now consider the curves below. Y is 2x squared plus 1. Y is 2x squared plus 3. Y is 2x squared minus 4. These curves have the same gradient function, dy over dx equal to 4x. They form a group of curves with same gradient function and only differ in their y-intercept. The curves have a general equation of y is equal to 2x squared plus c, where c is a constant. The process of finding equations of a curve for a given derivation is called reverse differentiation or integration. For y is equal to 2x squared plus 6, c is called the constant of integration. If we differentiate x raised to n plus 1 over n plus 1, we shall get x raised to n. Thus, if dy over dx is equal to x raised to n, then y is equal to x raised to n plus 1 over n plus 1 plus c. For example, if dy over dx is equal to 3 cubed, then y is equal to x raised to power 4 over 4 plus c. If dy over dx is equal to 2x squared plus 4x, then y is 2 over 3x cubed plus 4 over 2x squared plus c, giving us 2 over 3x cubed plus 2x squared plus c. Integration notation. This symbol is used to indicate that an integral is being calculated. Generally, it is written as integral of function x with respect to x. Thus, integration of, say, x cubed plus 2x squared is written as integral of x cubed plus 2x squared with respect to x. Thus, the integration of x cubed plus 2x squared with respect to x is written as shown below. That is, integral of x cubed plus 2x squared with respect to x is equal to 1 over 4x to the power 4 plus 2 over 3x to the power 3 plus c. Definite integration. Consider the figure below. The area under a curve was estimated using the trapezium rule before. For a small value delta x, the trapezium may be approximated to be a rectangle with width delta x and height the y coordinate. The total area bound by the curve, the x-axis, the lines x is equal to a and x is equal to b, the sum of the area of these rectangles, that is represented as shown below. But delta x of the rectangles have limits. These limits are obtained when delta x approaches 0, that is shown below. And the area at the limits is given as integral of y with respect to x, where this symbol is the symbol of summation, and dx is the limiting value of x. Thus, the integral of y with respect to x from a to b is the total area under the curve from x is equal to a to x is equal to b. Suppose we want to find the area under the curve y is equal to x squared. The x-axis and the lines x is equal to a and x is equal to b. Area is equal to the integral of y with respect to x, or area is equal to the integral of x squared with respect to x, which is equal to 1 over 3x cubed plus c. The value of a corresponding to x is equal to a is equal to a subscript small a. Area A includes the whole area from negative infinity up to and including x is equal to a, written as area A equal to 1 over 3a cubed plus c. Similarly, area B includes the whole area under the curve from x is equal to negative infinity up to and including x is equal to b, written as area B equal to a third b cubed plus c. This is illustrated in the figure below. Thus, the area between x is equal to a and x is equal to b is given by area B minus area A, which is equal to a third b cubed plus c minus a third a cubed plus c. This is called definite integral of x squared from a to b, denoted by the function below, where a is the lower limit and b is the upper limit. Hence, the integral of x squared with respect to x from a to b is equal to a third x cubed plus c with subscript x is equal to b minus a third x cubed plus c subscript x is equal to a, where a third x cubed plus c subscript x is equal to b and a third x cubed plus c subscript x is equals to a are the area corresponding to x is equal to b and x is equal to a respectively. This is usually written as below. When a definite integral is calculated, the constants cancel out. For example, evaluate the integral of 3x squared plus 2x with respect to x from 2 to 3. In our solutions, we shall have x cubed plus x squared under square bracket from 2 to 3, subtracting as above. After substitution of 2 and 3 into the equations, we'll end up with 36 minus 12, which is equal to 24. Area under a curve. An area bound by a curve, the x-axis, and lines x is equal to a and x is equal to b can be obtained by evaluating the definite integral of y with respect to x from a to b, where y is a polynomial in x. For example, find the area bound by the curve y is equal to x minus x squared plus 6, x is equal to 0 and x is equal to minus 2 and the x-axis. We can sketch the curve as shown below. The shaded region is the required area. A is equal to the integral of x minus x squared plus 6 with respect to x from 0 to 2. Substituting the values, we end up with 5 and 1 over 3 square units. Integration in kinematics. If we differentiate an expression for distance, we get the velocity function. If this function is differentiated further, we obtain the acceleration function. Suppose an object moves in a straight line such that the distance s in meters after t seconds is given by s is equal to 3t cubed plus 4t squared plus 9. Then its velocity v is given by the derivative of d, that is ds over dt, which is equal to 9t squared plus 8t. Acceleration is the derivative of velocity and is dv over dt, which is equal to 18t plus 8. It follows that v is the integral of acceleration, where a is 18t plus 8, and s is the integral of v, where v is 9t squared plus 8t. Thus, the integral of dv over dt with respect to t is equal to 9t squared plus 8t. The integral of ds over dt with respect to t is equal to 3t squared plus 4t squared plus c2, where c are constants. Example 2. The acceleration of a body moving in a straight line is given by 4 minus 2t meters per second squared after t seconds. The velocity v after this time is v meters per second, and the initial velocity is 5 meters per second. Find A, an expression of v in terms of t. B, maximum velocity of the body. C, the distance after 3 seconds. In our solution for A, acceleration is the derivative of velocity with respect to t and is equal to 4 minus 2t. Therefore, velocity is the integral of acceleration with respect to time, which is given as 4t minus t squared plus c. We are told when t is equal to 0, the initial velocity is 5 meters per second, and substituting we get c is 5. Therefore, v is 4t minus t squared plus 5. B. The maximum velocity occurs when acceleration is 0. Thus, 4 minus 2t is equal to 0 and t is 2 seconds. When t is 2 seconds, v is equal to 8 minus 4 plus 5, which is 9 meters per second. Finally, distance s is the integral of velocity, and it will be given by the distance covered between 0 seconds and 3 seconds. Therefore, calculating that and equating into the function of the integral of s, we find 18 minus 9 plus 15, giving us 24 meters.
One of the wonderful things about mathematics, I think, is that people are impressed. It's often seen as a very hard subject, and so if you've done math, it's often treated as an entrance requirement, as a credential to do lots of other things. And so one idea is that for example, some MBA programs, the only thing they require going into it is a good, solid math understanding. They can teach you all the business. They just can't teach you the math fast enough. And so I think that math, aside from obvious careers that require math, if you're going to go work in a department that does operations research or something like that, they'll want people with specific skills in mathematics. But math is often seen as a filter or as a screen for many, many other disciplines. And so I guess what I'm trying to say is you can think broad, because math actually is a solid preparation. It's a good credential to go into lots of different fields that people often don't consider at the beginning.